Well, hello everyone and welcome back. As you must be aware, we are working in this series of videos related with electromechanical conversion systems. And one very important element of those electromechanical conversion systems is the material that we are using for the magnetic interactions. So for that reason, we have been recording several videos related with magnetic material fundamentals. And today, the video is quite interesting because today we are dealing with one of the very important properties that is called magnetic susceptibility. The magnetic susceptibility is a very important aspect, a very important parameter defining the magnetic properties of the material. Is basically a measure of how much of a material will become magnetized if you apply a magnetic field. In other words, it's the capability of this material of be modify the magnetic properties when subject to external magnetic field. So in reality, this magnetic susceptibility, the term is becoming from the Old Greek and also the Roman Empire, because susceptibility is coming from susceptibilities in Roman, and that means receptive. And it's denoted with this letter G. That is a Greek letter that is G. What is important for us is that this letter G, that is the magnetic susceptibility, allow us to classify the magnetic material in terms of the alignment with the external magnetic field. So if this Greek letter G is positive, we call this material paramagnetism. And in other words, if G is below to 0, we say that is diamagnetism. So the magnetic susceptibility indicates whether the material is attracted or repelled out of magnetic field, but also a very high positive susceptibility will tell me that that is the material that I want to use in the electrical machines, because it will allow me to use the magnetic properties. In other words, if we have a G that is this magnetic susceptibility that is extremely high number, positive high number, I know that that is a ferromagnetic material. Well, but without further delay, let me go into this very interesting example today. As you can see over here, there is a statement and say the room temperature susceptibility of 3 materials are listed below. And in this small table over here, you can see that we have material A for alpha, B for Bravo, C for Charlie. And here you can see the numerical value of the susceptibility. Remember, the susceptibility is a number without units. And here you can see the susceptibility is very low and is positive. Here is very low and is negative. And here you can see material C is a bit high. So there are 2 basic questions over there. Question A, determine its relative permeability, and B, classify each material as diamagnetic, paramagnetic, or ferromagnetic. So the solution of this problem is extremely simple, because all my students must remember the previous class. You attend to the classes, to the lecture, and also there are some recordings around. So you must remember the equation defining the relationship between the relative permeability, mu r, and the magnetic susceptibility, G. So as you can see here in this equation, the relative permeability is equal to the absolute permeability divided by the permeability of the vacuum. However, for practical reasons, we will use the right-hand side of this equation that say the relative permeability is simple, is just the susceptibility plus 1. So Now the next step is just apply the numerical substitution for those three different materials. And as you can see over here, we are applying the equation for the material A, and in this case, the relative permeability is the susceptibility of the material A plus 1. And here we have the numerical substitution coming from the table plus 1. And we obtain here the relative permeability near to 1 and is positive above to 1 for the material A. Then we will do the same is this number, the susceptibility is negative and is very small, plus 1, and we obtain here a relative permeability below 1. Finally, the material C, we can obtain the relative permeability as the magnetic susceptibility plus 1. So substituting the number, you can see over here, 12,501. Now question B, the answer for question B is extremely simple, because what you need to do is remember these three rules that I told you during the classes. If the magnetic susceptibility is small and positive, voila, we have a paramagnetic material. But if the susceptibility is small and negative, well, we have dimagnetism. And finally, and the most important category for us, is if we have a very large susceptibility and this is positive, well, we have a ferromagnetic material. So now what we need to apply is these three basic rules. For instance, material A, you can see that the susceptibility is small, it's very small, exponent -5, and it's positive. So we have here a winner. This is the paramagnetic material. Material B, beta, bravo, you can see that this is a dimagnetic material basically because the magnetic susceptibility is negative. And finally, we have a winner here. This is the material that I want to use because the material C, you can see that the susceptibility is extremely high and positive. So this will give me the good magnetic property for my core, and this is a ferromagnetic material. So if I need to decide, I will go for this magnetic material for using in the magnetic core of my electric machine. So I believe that all of you now, you can see that this magnetic susceptibility and also the permeabilities, they are very important properties defining the magnetization of any material. So it's very important when we are selecting the final material that we need to use for the electrical machines. In this case, using ferromagnetic material, that will allow me to reduce the losses in the magnetic core, so the electrical machine will have a better or a lower losses. So this is all for this video. Thank you very much for watching, and I will see you at the next one. Bye now.